Hello. Today I will present my project on zero padding and frequency resolution in the Fourier transform. This problem was designed based on the lecture topic of DFT, FFT, and frequency analysis, especially focusing on a concept that is often misunderstood, like the difference between zero padding and true frequency resolution. In signal processing, we often use the FFT to analyze frequency components. When we want a more detailed spectrum, a common approach is to apply zero padding. However, many students can misunderstanding this and think that zero padding actually improves frequency resolution. So the main goal of this project is to clearly answer, does zero padding really improve the frequency resolution, or does it only make the spectrum look smoother? The signal used in this project is look like this, where the sampling frequency is 1000 Hz. This signal contains two frequency components, 100 Hz and 104 Hz. These frequencies are intentionally chosen to be very close to each other. This makes it difficult to distinguish them when the frequency resolution is too low. First, we can generate the signal using only 128 samples. The frequency resolution is 7.81 Hz, but the difference between the two frequencies is only 4 Hz. So in this case, the FFT cannot clearly separate the two frequencies, and the spectrum shows one broad peak near 100 Hz. Next, we can apply zero padding to increase the FFT length to 2048. Now, the frequency grid spacing becomes about 0.49 Hz, so the spectrum looks much smoother. However, the number of actual samples is still 128, and no new information is added, so zero padding only interpolates the spectrum and does not improve true frequency resolution. Finally, we can generate a longer signal with 2048 actual samples. And now, the frequency resolution is 0.989 of, so I'm sorry, 0.49 Hz. This time, the improvements come from having more data. As a result, the two frequencies at 100 Hz and 104 Hz are clearly separated, and we can see two distinct peaks in the spectrum. I'll show these results for execution of my MATLAB code. First, the time domain signals for 128 samples. Then the FFT magnitude spectrum, the zero-padded results, and finally the long signal FFT for 2048 samples. As you can see, the short signal has poor resolution. Zero padding makes the spectrum smoother, but only the long signal truly separates the two peaks. Let's summarize the three cases. For the short signals like n equal 128, it insufficient resolution. For a zero padding case, smoother spectrum but no real improvements. Then for the longer signal, true improvement is frequency resolution. The key takeaway from this project is zero padding does not increase frequency resolution. It only provides a finer sampling of the DFT, and true resolution depends on the length of the signal, not the FFT size. This directly reflects the theory covered in the lecture on DFT and frequency analysis. Let's see the conceptual questions in my project. First question is, does zero padding improve the true frequency resolution? The answer is no. Zero padding does not improve the true frequency resolution. It only computes the DFT on a denser frequency read. For our next, why does the zero padded spectrum look smoother? Because zero padding inserts additional frequency samples between the original FFT beams, making the plotted spectrum appear smoother and more detailed. For our last question, why does increasing the actual number of samples improve frequency separation? Because increasing the actual number of samples increases the observation time and reduces the FFT frequency spacing. So this produces a genuine improvement in the ability to distinguish nearby frequencies. Thank you for your attention. That's it.